Radioactive decay. The nucleus of an atom contains protons, which are positively charged, neutrons, which are neutral. We can represent it with a symbol. This has 6 protons, so it's carbon, which has a capital C. The atomic number gives the number of protons, which is 6. The mass number is the number of protons and neutrons. In this case, there are 6 protons and 6 neutrons, giving a mass number of 12. On the left here, we have carbon 12, which we've just met. On the right, we have another nucleus, which again has 6 protons, but now has 8 neutrons. Because it has 6 protons, it is carbon. The number of protons determines the element. So it also has an atomic number of 6. But now, 6 protons and 8 neutrons gives a mass number of 14. This is known as carbon 14. These are isotopes. The prefix iso means same. You might have heard of isotherms, linking areas of equal temperature, or isobars, linking areas of equal pressure. So isotopes have the same number of protons, different numbers of neutrons. Here we have a nucleus, and it is an isotope of an element, and some isotopes are unstable and will randomly decay. In this case, this nucleus has ejected 2 protons and 2 neutrons in one particle. There are 3 types of decay. We've just seen alpha decay. In alpha decay, the nucleus ejects 2 protons and 2 neutrons. This is a helium nucleus, also known as an alpha particle. It comes out at about 10% the speed of light, which is almost fast enough to go round the world in a second. Next we'll look at beta decay. In beta decay, a neutron, this neutron in this case, becomes a proton and ejects an electron. Let's just look at that again. The neutron is neutral. When it becomes a proton, we've gained a positive charge, but we've also produced the electron, which is a negative charge. So overall, we still have 0 charge. So a neutron becomes a proton, ejecting a beta particle, which is an electron. This comes out at about 90% the speed of light. After alpha or beta decay, an atom will sometimes eject a gamma ray. So here we have a nucleus which has undergone an alpha or beta decay, and it ejects a gamma ray. This doesn't change the makeup of the nucleus. Protons and neutrons have a mass of 1. Electrons have virtually no mass in comparison, about 1/2000th the mass of a proton or neutron. Protons have a charge of +1, with electrons having a charge of -1. This means that alpha particles have a mass of 4 and a charge of +2, 8,000 times the mass of a beta particle. Beta particles have virtually no mass and a charge of -1. Gamma rays have no charge, no mass. If atoms are hit by radiation, they can lose an electron. Let's just see that again. An alpha particle comes flying in from the left and knocks off an electron. This leaves the atom charged or ionized. It is now no longer an atom, it's an ion. This is ionization. Because alpha are the biggest and have the most charge of the radioactive decays, they are the strongest ionizers. Beta are weaker ionizers, gamma the weakest of all. But all this ionization uses up energy, so alpha is stopped by paper or a few centimeters of air. An alpha particle flying along meets a sheet of paper and is stopped. It will carry out a few thousand ionizations and quickly run out of energy. Beta will be stopped by aluminium. gamma is reduced but not stopped by lead.